again, my name is Cornelia Davis. I am your host today for this session. I'm so excited that you've joined. While we're giving it another minute or so for people to trickle in, because I know what it's like. Sometimes meetings run over and people want to jump back over into the next meeting. I have a question for all of you. So I will tell you out of full disclosure, and I'll repeat this again in just a moment for those people who join a little bit late, that I gave this workshop yesterday live in London. It landed pretty well, so I'm hoping that it's going to land just as well for you all today. While we were waiting to get started there, I posed the same question. And here's my question to you. And what I'd love you to do is just type your answer into the chat, if you would. The question that I have is, who's using Terraform? You can just say yes by typing that into the chat. I'll tell you that yesterday when I asked that, yep, I'm seeing lots of yeses using Terraform. When I asked that in the room, of course, with the title like, you've got Terraform, how do you orchestrate it? Pretty much I expected everybody to be Terraform users. So that is really great. I'm also going to just see if the numbers who are joining are, let's see, participants. We've got about 50 people so far. Let's see. I think we're going to go ahead and get started. I'll go back to the chat. Super. So just one more little logistics thing. You are all muted. You have the ability to unmute, but we're a pretty large group today. So I would ask that you, for the most part, keep yourself muted. I'll pause at certain times to ask for questions, especially you're going to see as we go through the demo, there's going to be moments where we're waiting for things to provision. And those are the moments where I will look for questions. If you would like, as you have the questions, please put them in the chat. And I'm watching the chat. And so when we get to those moments of pause, I'll look at the chat. When we have a longer moment of pause, I'll invite you to unmute if you want to, instead of typing it into the chat. Please feel free to type it into the chat. But if you'd rather ask it live, that is great as well. I think based on a timing perspective from yesterday that we'll have a little bit of time at the end, probably 10 minutes or so, maybe 15, to ask questions live. And then I'm just going to invite everybody to unmute and ask questions live. Okay, so with that, I'm going to go ahead and get started. And I'm going to share my screen, and I'm going to share my entire screen because I'm going to be switching between slides and live demo. So let me go ahead and share my whole desktop. Okay. And we will jump in. So again, the title of this workshop is You Have Terraform, How Do You Orchestrate It? And for those of you who joined maybe a little bit after I said this a moment ago, I gave this same workshop at PlatformCon in London live yesterday. We only had an hour yesterday, so I went through it at a pretty good clip. We have a little bit more of a buffer today. So I will probably pause a little bit more and take a breath more and let things soak in a little bit. The response was quite positive, and so I'm hoping that you're gonna find benefit from this as well. So let me introduce myself a bit more fully. I am going to get this out of the way. So again, my name is Cornelia Davis. These days, I'm a developer advocate at Temporal, but my involvement in the platform engineering space dates back longer than the term platform engineering has even been popular. I was part of Pivotal. I was part of the Cloud Foundry team, was pretty much there from the beginning, and was at Pivotal until literally the last day that Pivotal was an independent company right before they got sold or got purchased by VMware. That gave me the great benefit of being right in the thick of things when this whole microservices movement, this new architecture for cloud native applications came along. And so I was working with clients, I was learning it, I was teaching it. And at some point, Manning reached out to me and said, you seem to know something about microservices. Would you like to write a book? So I did that. Oh, wow, what an experience. And then, of course, when Kubernetes came along, I embraced Kubernetes as well, because from a architecture perspective, Kubernetes and Cloud Foundry shared a lot in common, and it was clear that the industry as a whole was really becoming interested in Kubernetes. I am going to teach you a little bit about the technology that I work on now. After leaving Pivotal, I stayed in the platform space. I worked at Weaveworks, and Weaveworks is the company that coined the term GitOps. So I was very involved in the GitOps movement for a while. And then most recently, before joining Temporal earlier this year, was a part of a company that did Kubernetes operationalizing of multi-cluster Kubernetes. So let's build something. So we're going to spend the vast majority of the next, hour and 15 minutes or so really going through live demos. So I promise you there won't be a whole lot of slides. My style, though, is that I am a very big believer in pictures and the 1,000-word thing. And so I'm going to show you a couple of pictures of what it is we're building so that you have that right mental model before we jump into the code. I think that makes the whole demonstration a little bit more understandable. So here's what we're going to. Don't worry if you don't see any words. Nobody's seeing words right now, because I'm going to do something a little bit different. I am going to show you the agenda after we've done each stage in the agenda, because I am somebody who likes surprises. And so I'm going to hold some of these surprises in reserve. Now, as we go through the agenda, you can see there that I put a little annotation on there that says I'm burying the lead. What I mean by that is when we do the first two things, the first two demonstrations, you might be yawning a little bit. You might be like, okay, so what's so special about that? I've seen this before. But when we get about to the third part in this agenda, I think I'm going to surprise some of you. So hang out until at least then, and then you can see that there's another big surprise, a finale at the end. So I'm hoping that you'll hang out for all of those things. So this is what we're going to build. And in fact, before we build that, I have another question for you. And if you could again type into the chat so that we can all see. So you've pretty much all said, yep, you use Terraform. What do you use to orchestrate it? Are you using a programming language? Are you using some type of a SaaS service? Are you using scripting? If you just want to share with us a little bit how you're orchestrating your Terraform today and how you're doing things like managing state files and those types of things. Okay, so the answers that are coming in, you all can see them, but I'm going to list them out here. So Jenkins scripted pipelines, CI/CD, so I see GitLab, CI workers, scripting. Yesterday we had some people, Ado, I'm not familiar with that actually. Pipelines, Crossplane, heard that yesterday. Azure DevOps, interesting, not a surprise there. Yesterday, we had a couple of people who said, oh, I'm using Python, I'm using Golang, and those types of things. So great. Thank you so much for sharing. And that gives you an idea of the various ways that people are orchestrating their Terraform today. So I'm going to show you a new way, and I'll tell you what that new way is as we get into the demos. So mental model of what we're building. So very, very simple use case. The idea here is that we have templates for the environments that we want to create. So the scenario is, hey, I have an IDP, for example, and developers can come to that IDP and request environments. They can say, hey, I'm going to launch something into prod, and here's the environment that I need. They can select from a number of templates, and then the automated tooling, and that's where we're going to spend our time, is going to generate those environments. And then over on the right-hand side, you can see here are those environments represented. Now, I am not modeling the template because I didn't want to diffuse from the real work that's going on here. So I didn't want to have abstractions that were in the way. So you'll see as we go through the code that you're going to see very directly in the code that these two resources, an EC2 instance in AWS and a DNS record in Cloudflare, are modeled directly in the code. I'm sure that you can all envision that you can templatize those things and you can add that level of abstraction. And that's something that you probably have in your IDPs. So this is the basic idea. We're going to orchestrate these environments that have an EC2 instance and a Cloudflare DNS record. Now, when it comes to that environment management tooling, we're using Terraform. We're going to do Terraform applies for the EC2 instances, and we're going to do Terraform applies for the DNS records in Cloudflare. Now, for the actual tooling, the orchestration that pulls these things together, that's where we're going to use Temporal to orchestrate it. Now, let me take just a moment to tell you about Temporal. So yes, I work for Temporal, the commercial entity, but I'm not here talking to you about the commercial entity today. I am talking to you about the open source project. Temporal is an open source project. It's not open core, it's open source. The entire, all the functionality that is available in Temporal, and the business entity, of course, offers it as a cloud service. We have a SaaS service. That's how we make our money. And generally, the way customers start is they have started using the open source. And when they get to the scale where they don't want to manage the Temporal service itself, then they move over to cloud. Some of them never move, and that's okay too. Remember, I'm a developer advocate, so my goal is to help you all developers embrace this technology, commercial or not. So Temporal is open source. Every capability that you have, every feature that you have up in the cloud offering and the commercial offering exists in the open source. So we don't hold anything back in the open source. The license is MIT for the most part. You'll see in a little bit, I'm going to tell you a little bit more about SDKs. One of the SDKs, because it has a longer lifetime, and came out of, I'll tell you where this project originated from in just a moment. That one is Apache licensed, but virtually everything else is MIT licensed. So very, very permissive license. Now, where did Temporal come from? Temporal came from a project that was born out of Uber. And the project name is Cadence, also an open source project used by folks outside of Uber, for sure. It's a valuable project. But our founders, Maxime and Samar, built Cadence. They were the founders of Cadence when they were within Uber. And then about a little more than 5 years ago, they left Uber, they forked Cadence and built Temporal from that. They spent a year changing an awful lot from the Cadence project because they had learned a lot in the meantime. So they had the benefit of changing a lot in the year. And then, of course, it's diverged a lot from the Cadence project as well. And so it really is serving, its goal is to serve many, many, many users, not primarily Uber. So that's what Temporal is. And I'll tell you more about Temporal. You'll learn about it over the course of the session. So moving that a little bit to the left-hand side, of course, we know that when it comes to Terraform, state management, state file management is one of the things that you need to do. And so I'll show you this when we're in the IDE, but the way that I'm modeling this in the IDE is I'm just storing the state files locally. So the implementation that we have here is managing multiple environments, and we will generate multiple environments throughout the demo. And the way that I'm managing those state files is that you can see here that under Terraform configs, I have AWS and I have Cloudflare. And then within the state subdirectory, and you can see here that in each one of those places, I have the Terraform config file. So I have a main Terraform for AWS and another for Cloudflare. And then I have a subdirectory called state where I'm putting the different environments and storing the state files in there. So I'm not doing anything fancy with state file management, except when we get to that final, at the end, the final surprise at the end, you'll see that there is something that orchestrating with Temporal does offer you in terms of state management. We aren't going to store those state files for you, but we'll help you keep track of them, which I think is half the problem. Okay, so we're ready to jump into live demo. So I'm going to bring up my cheat sheet here and make sure that I don't forget things. Where did hang on. I had it up, there it is. Okay, so For demo one, and I'll give you a URL at the very end. There is a Git repository. At the moment, it just has a README in it that says, hey, I've been working on getting as much into this demo as possible, that I haven't managed to get it polished up to publish yet. But I promise you it'll be there within the next day or two. Probably going to be working on that right after the workshop today and get that published. So rather than showing you what I'm going to demo, I'm going to demo, and then I'll show you what we demoed. So I'm going to move over now into a command prompt. And what I have here is two windows. In the upper window, what you see here, and you can see that I already ran this to make sure that my demo was working. By the way, demo gods, please shine your light on me. What I have up here is I have the actual orchestration running, and you can see that there's some outputs. Interesting. It looks like I may have had an error in the last one. Oh, and I bet I know what it was. I bet I had an internet problem. So we won't worry about that. We'll just go forward with the demo. So here again is where the orchestration is running. And in the lower window is where I'm going to essentially execute the commands that would sit behind your IDP. So if the user goes to to the IDP and says, hey, please create me an environment, what would happen behind the scenes is it would run this action, which is, you can see that it's an application called Starter, and it says action create. So I'm going to go ahead and click OK on that. And again, I'm going to hope that the demo gods are smiling on me. While we're waiting for this to run, I will go over and show you the code. But what you can see here is that you can see some Terraform stuff happening. Terraform has been successfully initialized, and now we're doing a Terraform apply. So let me show you what that looks like over here. So I have two files that we're going to go back and forth between. I'm going to start over here in the workflow file. And it's super simple. And that's what I meant by, in this first demo, you're going to think, what's the big deal? This doesn't look any different. And you can see here, though, that I'm deploying the AWS infrastructure, and then I'm deploying the Cloudflare infrastructure. Now, what I've got here is Golang code. I mentioned that Temporal supports a number of different SDKs. What you do when you're building your orchestration code is that you can build it in whatever language you want. We don't support scripting. We don't have an SDK for Bash. We have an SDK for a bunch of different programming languages. So we have SDKs for Go, Java, TypeScript, Python, Ruby, PHP, and .NET. So wide range of programming languages. We really believe that so much of what you want to do, whether it's orchestration or it's microservices orchestration, or even if it's AI agent construction, doing so in a programming language is going to give you the most control and the most power to be able to build your orchestrations or whatever your business application is, or whatever your application is. So you're going to see all of the orchestration that I'm doing here, I'm doing in Golang. I could have done it in any one of those other languages as well. So again, you can see here that I've deployed the AWS infrastructure and I've deployed Cloudflare. Now, let me go over into the user interface for Temporal. I want to hide that. I think there's a way. It keeps popping up on me. Hide video panel. I think that, no, that didn't do it. Oh, there we go. Hide floating screen controls. Thank you. So thank you for your patience. So what I've got here is I have the user interface for Temporal. And again, I am running this all open source. There's not a single stitch of any commercial offering in any of the demos that I'm doing here. So this is part of the open source. You can see here that I'm running it locally. It's on localhost. And this is the environment. This is the workflow. So this is the orchestration that ran to provision that environment. And if I click in here, you can see that it shows you exactly what happened. It shows you that I deployed the AWS infrastructure, and then I deployed the Cloudflare DNS. So it takes, looks like it took about 48 seconds or so for the AWS EC2 instance, about what I would expect, and then a second or two for the DNS record. Down here, you can see all of the different tasks that were executed as a part of that. And I'll explain more of that as we go. So that's the first demo. So you can see pretty simple. Now I'm going to also use Terraform to destroy this. So I'm going to do a destroy. And then I have to give it the environment because I have a couple of different environments running here. Environment, can I spell? ENV dash, and there's the number 8519. And that is going to launch another workflow. So if we come over here, you can see it executing. So we'll go back to the dashboard. And you can see here that it's running the orchestration that does a destroy. So right now it's destroying that instance, and then you'll see it also is going to destroy the DNS record. And we won't sit here and watch it. I'll leave this window up, and we can take a look at it when we come back, and it'll have been destroyed. So that, and let me just show you just to prove the point. So we can see here that I have the running instance, that's the one I had earlier, and then I have the one that terminated. So if I come back over here, sure enough, the termination has finished and the DNS record was removed as well. So there should be no DNS records. I think we had an error on the earlier environment. No, it recovered. So that's the whole thing. So that's the DNS record from the earlier test that I did. Okay. So not too exciting yet, but I'll come back to that in just a moment. So what I'm going to do now is I'm going to stop my orchestration and I'm going to do a git checkout of demo 2. And now I'm going to start the orchestration again, and I'll show you how the orchestration has changed. This scenario, it was already checked out. I'll start the orchestration. Now I haven't created an environment yet, so it's just sitting there waiting. But the use case that we're going to see in the second orchestration is, okay, great. I've got these 2 steps. I'm provisioning the AWS instance and then the DNS record. I want to have a human in the loop. So I want to have orchestrations, and this can be tricky. Like, how do you orchestrate human in the loop stuff? Do you have a script that runs part of the way, and then you have a script that runs the rest of the way, et cetera? And so human in the loop for things like infrastructure provisioning, approvals, for example, are not that unusual. So we're going to go ahead and do a create again, but this time I'm going to ask for approval. And so the way that I'm going to ask for approval is the way that this particular, I'll show you the code in just a second, but the way that this particular example works is that if you don't provide this command line argument, it's going to consider it pre-approved. So for example, certain teams might be pre-approved, or in certain environments, the DNS records might be pre-approved, but maybe when you're deploying out into a very special prod environment, you need to have approvals before you create the DNS record. So the orchestration is written so that you can have it pre-approved or you can wait for approval. So in this particular case, we're going to wait for approval. So I'm going to go ahead and start that. Now, let me show you what the code looks like. So I did a checkout, so I'm still in the workflow. So I've got my, I've just updated that particular workflow. And so what you can see here is that I'm still deploying the AWS infrastructure, and I'm still deploying the Cloudflare DNS. But here, in between, I have, if the DNS entry is not pre-approved, okay, comment isn't that great, but if it's not pre-approved, then I'm going to wait for an approval. Now, this here is an abstraction that's available as a part of the temporal programming model. And I'm going to summarize the temporal programming model in just a moment. But one of those abstractions is specifically something that allows you to inject into a workflow. It allows you to say, all right, I've got a running workflow, but now I want to insert some additional information into that running workflow. Let me show you that the workflow is in fact running. So if I go back here, you can see here is the workflow that is running for that particular orchestration. So I come in here and you can see that deploying of the AWS infrastructure has finished. And now it's waiting. It's just waiting for a signal. So let's go ahead and deliver that signal. Because the workflow is still running, I'm just going to Control C out of that. That isn't going to stop the workflow. The workflow is running. That was just my launcher. And you'll see that behavior change later on as we evolve the demo. But what I'm going to do now is I'm going to come in here and I'm going to do an approve of environment equals, and the environment here is 4984. So env 4984. And I'm going to click enter, and then I'm going to try to see if my left hand will do the right keystrokes and get back over to the UI very quickly. So hit enter, we come back over to the UI, and immediately you can see that this changed. When I hit that approval, that is what delivered the signal, and the signal was a, hey, I've approved this. So you can see here that I input the value true. It was waiting for an input. If I had inputted the value false, it would have said, if I had said, nope, this is not approved, then I would have had the input signal of false. But I got an input signal of true, and then it deployed the Cloudflare DNS. Okay? So this is kind of cool already. So not every orchestration technique that you all are using, especially those of you who said you're using scripts, scripts don't really have a first-class mechanism for injecting signals into a running script. So that is something that is pretty cool. Now, I want to show you something else. And then I'm going to talk a little bit about this. Now, I'm going to do another create. And I am going to wait for that approval. And what I want to show you now is that we're going to do that, and let me see if there was anything else that I wanted to say. So nope, I think that's all I wanted to say here. So we're going to wait for this particular, let me go back over here. We're going to wait for the AWS infrastructure to provision. I'm holding a super cool part of the demo until later, and you'll see that in just a moment. But we're going to wait for this provision. We're going to be waiting for the human in the loop approval. And so this should be just a few more seconds. And then I'm going to do something that might surprise you. So hopefully this is just going to be about 2 or 3 more seconds. It's been taking about 45 to 60 seconds. We'll come over here. Yep, there we go. So the AWS infrastructure is provisioned. And now I'm waiting for that approval. So the workflow is running. I'm going to do something that might shock you. I am going to kill my orchestration. So I'm up here in the upper window, and notice that I have stopped the orchestration. Okay, it's not running anymore. But I haven't told you about the architecture of Temporal. So your orchestration is running, and I'm running it here locally on my machine, but it's connecting to the Temporal service. So that workflow is durable. It is everything that it needs, everything that it knows about the running workflow. The fact that it's already completed the AWS infrastructure provisioning, that's all maintained in the Temporal service. And again, I'm running the Temporal service locally as well, but I could be running it anywhere in the cloud. It could be a remote service. So now I'm going to do something interesting, and I'm going to restart my orchestration. If we come back over into this window, you can see everything's fine. I'm going to go back here just to show you the workflow is still running. Okay, all of that. And now I can come in here, and you'll notice that it doesn't try to rerun the AWS infrastructure. So if I come over here, you can see that I'll refresh the AWS console. There's nothing new provisioning. They're all running. This is the one that just provisioned. So it's still initializing. That takes a little while, but they're all up and running. And now I'm going to come back here, and I'm going to do that approval again. And this time I am in environment 1291. And sure enough, when I come over here, the signal came in, and it did the second step of the orchestration. So this is the first big surprise that I wanted to show you, is that your orchestrations here, just that code that I'm running, is durable. That means the orchestration itself can die. And when you bring the orchestration back online, technically that's done through what we call a temporal worker. So let's say your orchestration is running, let's say in some CI/CD tool, you run that again and it brings it back up and it says, oh, I'm already running this workflow. I'm not rerunning the workflow. I'll just pick up where I left off. So that's a hugely powerful feature that Temporal has, is it keeps track of how far you've made it in your application. So in this case, how far you've made it in the orchestration, and it picks up where you left off. No more orphan resources. That's the big epiphany here, is no more orphan resources. So let me go back. I'm going to pause for questions really soon, but let me go back here. And so, like I said, I've been holding all the surprises. So basic Terraform orchestration, yawn, no big deal. Human in the loop, okay, maybe that got a little bit interesting. But then that durability demo that I just showed you, whew, that's where it gets really interesting. Now, here are the temporal programming primitives. Everything that I've been showing you here, and wait, I actually didn't show you all of the demo. I want to show you something else. So I'm going to come out of this. I forgot to show you one other demo. I didn't look at my notes. So I'm going to come back over here into my code. And you'll notice in the code here that we've been looking at the workflow. The workflow is the primary orchestration. But you'll notice that each place where I've done the provisioning, so provisioned the AWS infrastructure or provisioned the DNS, I did so through something called an activity execution. Now, activities are a primary primitive in Temporal. And what you do is anytime you're making a downstream request, a request that goes outside of your process. So for example, invoking the Terraform CLI, which that's the way that I'm invoking Terraform here, is through the CLI. That's external. It's not in my process. It's a distributed systems call. So anytime that I'm doing a distributed systems call, I wrap that distributed systems logic, that call, in what we call an activity. So over here, I want to show you what the activities look like. So here's an activity. Here's the activity for AWS infrastructure. And this could have been refactored a little bit more nicely, but I didn't worry about that refactoring. You can see that it's setting up things and it's figuring out whether it needs to create that new directory in the state subdirectory. And it's doing all of that. But right here, you can see where it's making that external call. Here's where it's making that CLI call and invoking Terraform. Okay, and I basically have the same kind of template down here for Cloudflare DNS. Again, I'm making the call to Terraform. Now, the other thing that I want to show you here from a durability perspective is if we go to the top of this file, you'll notice, oh, and I want to, in fact, do it on DNS. You'll notice here that there is a flag that is there for demo purposes, should fail. So when the flag is true, I am simply going to return an error from this. So let me go ahead and because I changed my orchestration, I'm going to stop the orchestration and start it over again. And I'm going to do another create. And I don't think in this case, in this case, I don't need to wait for the DNS approval. We'll just do a simpler use case. So the create is starting. Now, the interesting thing here is that another durability feature that, and let's go back, let me show you the workflow. So here's the workflow running, and it's going to be the same familiar workflow that we've been looking all along. So it's deploying the AWS infrastructure, and then it's going to deploy the DNS after the fact. But if you remember, that activity, which is going to make a downstream request to Terraform, which is in turn going to make a downstream request to Cloudflare, is failing. So the activity is coming back and saying, oh, sorry, I'm failing. And now you can see exactly what's happening here, is that the DNS operation is failing, and you can see here that it's incrementing the attempts, attempt 5 of 10. Now you can configure this however you want, and let me go over here and I'm going to kill my orchestration. You can think of what I just did in there as introducing a bug. This is one of the other really cool things about Temporal is this is not only used in a case where the downstream service is having problems. Sometimes you might, in the middle of an orchestration, realize that you have a bug in some of your orchestration logic. And in fact, I injected a bug right here when I set that value to true. So I'm going to fix my bug. Or in this particular case, let's say the reason it was failing, because there's errors that are further down here as well. If the reason that it was failing was because of a network availability blip, eventually that network availability blip will correct itself, and then you'll see the following behavior. So we will set that to false. So we fixed the bug, we'll rerun our orchestration. And if you remember, I showed you before, oh, there, and it already fixed itself. I showed you before that it knew exactly how far it got in the orchestration, so it didn't try to deploy the AWS infrastructure again. It simply picked up where it left off. So you can see this light green bar that goes all the way across to here, and then it was able to execute. If we click on that and we scroll down, we can see here that it was on the 6th attempt at invoking that Terraform apply that it was finally successful. So that's another bit of durability. You'll notice that I didn't have to program that durability in my code at all. I didn't have to program those retries. That is something that is implicitly part of an activity. So remember, there's an SDK. It's the SDK that implements the retries on your behalf. You, as a platform engineer, can simply program your happy path on your orchestration, and Temporal will take care of all of these potential challenges. Okay, so oh yeah, so let me tell you about the programming model, and then I'm going to pause. I'm going to take a look over at the chat window and see if there are any chats. So if I go back over here, let me finish telling you about the programming model. I think this is where we were. Yes. So as I mentioned, the workflow is kind of what we consider the application main. This is where your primary orchestration is. Activities are used for external calls, and then signals and updates are ways for you to inject into a running workflow. The specific use case that we looked at here was human in the loop. You can have all sorts of activities. You could have Slack messages that inject, Slack bots that inject into a running workflow. You can have something dropping into a file system inject into a running workflow, all of those types of things. So you can do whatever you want. Our use case was human in the loop. Now, we also have an abstraction that I'm not going to show you today, but you also, while a workflow is running, you have the ability of querying into the workflow. So you can go in and see where you are in the workflow. You can look up values and those types of things. So these are kind of the core temporal programming primitives that you're going to use to execute your orchestrations. Okay, with that, let me go over into the Zoom. I'm logged in 2 places. So let's see. Hi, I see a comment that says, never seen a programming language doing Terraform. Here we are. And as HashiCorp has that, yes. And of course, Temporal Enterprise does some of the things that I'm showing you here as well. So yeah, is Terraform running via external run command? You can see I've showed you that logic in the meantime, that I'm just executing via CLI. Okay, so we went over the workflow, and now we're going to jump to the next part of the demo. Let me go back over into my cheat sheet here. I talked about the programming model. So now I want to show you something else. And I'm going to come back over here into my demo environment. I'm going to close my orchestration, and I'm going to get the next version of it. So git checkout, demo 3. And I'm going to run that orchestration again. So now it's waiting. And we're going to go ahead and do a create, but this time I'm going to do a create with a DNS approved flag again. So we're going to wait for approval. And the use case, so I've gotten that started, and I'm going to come over here and I'm going to show you what is happening in the UI. So if we come back over in here, you can see that we have a new workflow that's running. And it's going to behave the way that you saw before. So it's going to provision AWS, and then it's going to wait for an approval. But I have added something here where I have said, well, my business case that I'm implementing is I'm going to wait for approval. But if the approval doesn't come in within some time period, then I am going to cancel it. Now, I'm not going to go ahead and approve this. I'm sure you can imagine that if I went and I clicked the approve, you would get a little purple button, little purple dial in there, and then it would provision the DNS and the workflow would be finished. Instead, I'm going to go ahead and let this timer, so I'm very generous. I gave the approval 30 seconds. They better be at their terminal and be hitting approve right away, of course, for demo purposes. And I'm going to give them 30 seconds. And if they don't approve it within 30 seconds, then we are going to say, this workflow is this environment provisioning has not been approved. So I'm going to dial it back, and I'm going to, like a saga pattern, I'm going to undeploy my AWS infrastructure. I'm going to delete that. And so if I come over here in the instances, if I've done it quickly enough, you should see that there's one that is shutting down. And it went faster than I was able to show you. I talked for too long. But if we come over here, you'll see that indeed it deprovisioned that AWS instance. And you'll notice now that at the top, it has a red bar. And that indicates that this particular workflow failed. Now, I made that decision, and I'll show you the workflow code in just a second. I programmed my orchestration that way. I could have programmed a different orchestration, which would be to say that, hey, if this hasn't been approved, then I'm going to escalate it. I'm going to send the approval request to the manager of the person who didn't approve it, because maybe they're on vacation. So you can program whatever logic you want there. The business logic that I just programmed here was just this very simple workflow. So if we come back over here in the workflow to show you what that looks like, I again have my deploying of the AWS infrastructure. Down here, I have the deploying of the Cloudflare infrastructure, and sandwiched in the middle is the part where it says, if it wasn't pre-approved, then I'm going to set a timer. So you can see here that, remember, we had a selector a selector is basically something that's waiting for input. And I've created another selector. My selector for the approval is still up here. This is the selector for the approval, but I've created another selector, which is basically a wait. And you can see that it created it as a future, which is a timer. And then the timer right here, the timer future this is the workflow timer that we created. And you can see here that it's a 30-second timer. So it's the same basic structure. Now, the interesting thing, that I didn't show you, and in fact, let me start this again, because I want to show you something else. I forgot about this part of the demo. And I'm going to show you this in action in just a moment, is that you might have noticed that I referred to this not just as a timer, but I referred to it as a durable timer. You'll notice here that I'm not using like sleep. I'm not using any kind of Golang sleep mechanism here. I'm using something from the Temporal SDK, from the workflow, and I'm setting a timer there. So for example, if I come back over here and we see this workflow in action, it should be provisioned in just a moment. I'm going to do something interesting, and I suspect that some of you may know where I'm going with this. So the timer should start in just a moment. Okay, so the timer has started, and now I'm going to come over here and I'm going to kill my orchestration. And I'm going to kill it for at least 30 seconds. because the whole point is, if we go back over to the code, this timer is not executing in my orchestration process. The timer is executing within temporal. And that's what I mean about it being a durable timer. So if we come over here, you'll notice that the timer has expired. Now, if I was just doing this in a regular programming language using, let's say, asleep in Java, or I was using bash scripts or something like that, when I killed the orchestration, my timer would have gone away with it. Now, if I come back here and I start my orchestration again, and we come back over here, you'll see that immediately, as soon as I came back, my orchestration came back, it said, oh, the timer was expired, and it started the deprovisioning process. Okay? So durable timers are another concept that we have here. So going back into my slideshow, that is in fact the next cool thing that I showed you is durable timers. So here's a pictorial. I've been talking about how the temporal service, which can be self-hosted, that's what I'm doing here, or it can be up in the cloud. Even your self-hosted can be in the cloud, has all of these primitives that keep things durable are part of the temporal service. So we've seen retries. Those were happening. Those were being controlled. Because remember, the retry wasn't just in my local logic, because I killed my process and it came back. The retries were being managed through the temporal service. Timers, I'm not in this talk going to talk a lot about state. We'll talk a little bit about it later. But one of the things that I haven't told you is that all of these interactions, anytime that I'm going between the orchestration and these external calls, all that is happening over event-driven architectures. So we do the queue management for you as well. You'll notice that I never had to provision queues. I never had to, do any of that. That was all handled for me by temporal. So you can see here that here's my orchestration, EC2, DNS, S3, RDS. I just noticed that this needs to be updated. We have Ruby in terms of the SDK as well. Okay, so I've added to the programming primitives these durable timers. We also have something called schedules that you can use to schedule behaviors. Okay, so now I want to show you another demo. I'm going to come back over here, and I'm looking at my watch. We're doing just great on timing. So I'm going to, I don't need to close my orchestration. I'm just going to go ahead and do another creation. We don't need to wait for DNS approval in this particular case. I'm just going to do creation. And so you can see here that Terraform has been successfully initialized. And if we come over, we can see that the workflow has started running. I hid that a while ago and it has come back. Hide floating meeting controls. There we go. So if I come back to the workflows, you can see that it's in the middle of doing that provision. And now, before I hear back from Terraform, I'm going to close my orchestration. Okay, I'm going to kill my orchestration. So what's going on here? Let me show you another picture. So what I've got here is, I go into slideshow, is I just invoked a Terraform apply from my orchestration. The orchestration is what's happening in this temporal code, the Golang code. That is making a downstream request to Terraform. Yeah, it's on my local laptop, but it's an external. It's an out-of-process request. It's using the Terraform CLI. That in turn is making a call out to AWS to provision that infrastructure. So the question is that if my orchestration dies and I bring it back on board, remember I've been saying all along that Terraform knows how far you've gotten. Well, it knows how far you've gotten because it knows when you've gotten back responses from an activity. So as I'm orchestrating my code, and I'll go back to the code here. So what happened is that I launched this activity and I was right here in the workflow. And this is a blocking call, the way I've written it right now. This is a blocking call. I could have made it async, but I didn't. It's a blocking call. And so right here is where my program execution was. And when Terraform, when I killed the orchestration, that is, I killed this code, it has no idea how far into the activity it got. Did it die before I got to the Terraform CLI request? Did it die before Terraform had a chance to issue a request to AWS? Is AWS down? Did AWS start provisioning it? But Terraform died in the meantime, so it never got back the response, etc. So you can see that's what I was getting at with this picture is you don't know where the crash happened here. So what do we do in this particular case? So when I come back over here, I'm going to start my orchestration again. And let's take a look at, that's how it's coming back. I'm going to come back over here into the workflow. Oh, that's a different workflow. Come into the new one. And what you can see here is that it in fact completed right after I restarted the workflow. And I'm going to show you what I did in just a moment. In fact, I'll show it to you in this board here. So what we did was if we take a look at this activity, which deployed the AWS infrastructure, you'll notice that it took 2 attempts. So the first attempt, it did in fact reach Terraform. And Terraform did in fact launch the request to AWS in this particular instance. But because we never heard back, because the whole thing died before then, Temporal says, well, I have no idea whether this code, this line of code, I have no idea whether this was successful or not. So I'm going to run this again. It knows that it got to the activity, so it won't rerun this stuff before it, any activities before it, but it will rerun this activity. And here's the brilliant thing, is that activities, and you might have noticed that on an earlier slide, activities should be idempotent. And you can see here on the slide is in fact, it says here, workflows must be deterministic. And I won't spend a lot of time talking about that here today. We can certainly take questions if we get to that point, if we have time left over. But generally, workflows must be deterministic, but the activities should be idempotent. Now, if you're implementing a call down to, let's say, a withdrawal from a bank account, that API for the withdrawal would be great if it was idempotent. And in fact, most financial services applications are going to have an idempotent characteristic for actions, APIs like withdrawals and deposits, because that's really important. But you might have a downstream service that doesn't have idempotent behavior. And if it doesn't, then you need to layer on some idempotent behavior over the top of that downstream API. But as you all know, because you're Terraform users, that the vast majority of resources, Terraform resources, are idempotent. So in this particular case, I didn't need to do anything special. I could very safely just make it an idempotent call. So what actually happened in this particular case, if I go back, is that we reran this, which reran the Terraform apply. But because that is idempotent, when that message got down to AWS, AWS said, oh, I already have that infrastructure. And it didn't actually apply down at the AWS level. Okay, so that's something that is super, super cool about, I keep losing my cursor. So that is something that is really great. Oh, and in fact, I wanted to stay there for just a moment. Sorry about that. So there Terraform generally is. And so that was our discussion about determinism and idempotence. Okay, I have one demo left, and this is my absolute favorite. This is the piece de resistance from this entire demo. frankly, I think a lot of what I've shown here is pretty darn cool. I didn't mention to you how long I've been at Temporal. I've been here for about 4 or 5 months, although I started playing with Temporal last year and I got so excited about it, I needed to join the company. It is really, really wicked cool technology. It's not something I've ever seen before. But let me come back here. Now, have a look at this. These are all the different workflows that I've been running since we started this demo. Now, you might remember that I did a destroy. I don't remember. I think I did, yeah, here we can see that I did a create for environment 8519, and I did a destroy for 8519. I did creates here. I would have to look through, I don't think I did destroys. These here, because we saw those running, I think these did destroys. So if I click down in there, yep, sure enough, it did destroys. But if you have a look, these workflows are kind of executions that happened and then finished. And so I cannot, based on the activities that happened here, I can't really easily figure out which environments are still up and down. Now, you might be saying, well, that's okay, because I have tooling that keeps track of all the different environments that in this state. And by the way, the state files are there, so I can run a script that runs against my state files, and I can figure out which environments are up and those types of things. But I'm going to show you something else. I'm going to come over here, and I'm going to move to my final demo, which is git checkout demo 4. Okay. And now I'm going to start my orchestration again. I will show you the code for this, the orchestration code. And I'm going to, let's see, I don't think I need any approvals in this case. Actually, I am going to do an approval. So we'll see that happening in just a second. I think this does have a timer, so I do need to pay attention to this. So the first part of this demo is going to look very much the same. Let me go ahead and bring my workflow up so it's running. The first part of this demo is going to be very much the same, and then we're going to see the timer fire, and then we're going to do an approval. Let me get that approve. Approve. It's kicked off. I'm going to wait. And now some of you might be thinking, if I approve it ahead of time, well, let's not do that. I don't think I tested that, and I don't want to anger the demo gods today. So this will fire in just a second. Then we're going to approve it. Okay, so now I'm going to approve. And the DNS record was created. But wait a second. The workflow is still running. I go back to the workflows. Oh, it's still running. Huh. Okay. And I come back here. Let me do another create. And this time I'm going to create one without the approval. Okay, so come back here. I've now got a second workflow running. Well, it finished. Why is it still running? Well, here's what I've done. I've turned my orchestration into a digital twin. Every one of my environments now is going to have a digital proxy for that environment. And that digital proxy is a workflow. If you look in our docs, we sometimes call these entity workflows. I tend to like the digital twin terminology better because it's a little bit more industry recognized. So while this is running, there's an environment running, and I can do all sorts of things to it. I can destroy it, or let's say I want to update it. So I've got something in here, and we can see that just updated. I'm going to come in here, and I'm going to do an update of my environment, and I can do either one. I will do environment, and this is another one of those signals. Remember I showed you signals earlier? env $8.99. Let's see what happens over here. Sure enough, there's a signal that comes in and it says, oh, okay, I'm going to update the AWS infrastructure. Well, in this case, it was a no-op. That's why it came back so quickly. The original deploy took whatever, roughly a minute, but this time it came back very quickly because it didn't have to do anything. So let's now come over here and let's make it do something. So remember I showed you this file structure earlier where I said within my Terraform configs, I've got AWS Terraform, and here's the main for that. So you can see here that I'm running this AMI right now. So I'm going to switch out that AMI. And I'm going to save the file. And I'm going to issue that update request again. So action update on that infrastructure. As you can see that the update signal came in. It's now running that activity, that deploy AWS infrastructure activity. And you'll see that it's going to take a little while. Let's come over to the AWS console. And what you can see is that because it was a change in AMI, I am shutting down the instance that had been running, and I'm going to create a new instance. So it is doing exactly what Terraform asked it to do. Terraform recognized that there was a change in the state file. I'm sorry, a change in the configuration, the resource configuration, and it sent those changes down to AWS. And AWS is now updating. So if we were to watch this for a little bit longer, let me refresh it. We should see it shutting down. Doesn't usually take that long. We should see the new one provisioning. Pending, there it is, right at the bottom. So this is a new one that is getting provisioned. So if we come back over here, we can see that, oh, it just finished. And then it did a deploy of the DNS record because I got a new IP address. I had to do that. And it keeps running. Now, if I come back over here and I take a look at the other workflow, notice that I changed my resource configuration, but I didn't run an update command on this one. So the digital twin for my second environment shows that it shows the entire history. And I mentioned this earlier. Let me go back to this rich history on this one where we've done all of those different things. You can see all the things that we've done to this infrastructure are recorded here. So you can see the timer was canceled. That's when the approval came in. Remember, the timer was a 30-second timer. As soon as the approval came in, it said, oh, stop the timer. We're good to go. So you can see every single one of these activities. And if I were to click on this UI, you could see that the DNS Cloudflare deployment there, you can see the updates and you can see the fact that it was a no-op. All of this, we call this the event history. So the temporal service is maintaining that event history. Now, the other thing that I could have done is I could have, just as I've been doing all along, is I could have come in here, and in fact, I can kill my orchestration. I'll start my orchestration up again. And by now, hopefully you totally are expecting that everything is just going to keep running as expected. But here's the interesting thing, is that because these workflows are digital twins, all of that state, remember I had a picture way back here where I said, I'm going to tell you a little bit more about, we looked at timers, we looked at retries, I talked a little bit about this event-driven architecture, and I said, I'll mention something about state. All of that state, so for example, keeping track of where the state files are, that's part of the state of this workflow. So you don't have to keep track anymore of the orchestration and the way that it's tied to particular state files. That's all stored within the digital twin, which that's why I call it the piece de resistance. I love the digital twin concept. So we are coming to a close here. So we talked about deterministic and idempotent, and now we talked about digital twins. So I think that's pretty darn cool. Let me come over here and take a look at the chat and see if there's any questions. I do see some questions. So here's one. What about the reconciliation loop? If a manual change is done in AWS, does Temporal Worker detect this and sets the infrastructure back to its desired state? So that is one of those cases where Temporal doesn't recognize that. But if you had something that recognized that, because Temporal, it is just talking to Terraform. That's all it's doing, is it's talking to Terraform. Now, if you have something that recognizes that something's changed, and I will admit that I'm not a Terraform expert, so maybe there's something in Terraform that does this, you know what you can do is you can have an update. You can use that trigger to trigger a signal into the temporal workflow and have it reapply the configuration. So that's one way that you can do it, especially now that you see we wouldn't have been able to do that before the digital twin thing. Before that, we would have had to like figure out like which workflow do I need to run again. But in this particular case, because we're now running a digital twin for every environment, we just have to signal a workflow to the right digital twin, send a signal to that workflow. So hopefully that answers the question. I see another question here, which is how the temporal solution compare to hash CDK. I honestly don't know. Let me keep reading the how about more complex case like governance, data. For instance, I have policies for the infrastructure like Azure Blueprint or using OPA, Open Policy, to define what can be deployed and so on. So the question is, so I get the question. I'm not familiar with CDK. So, but here I'm going to speculate a little bit. And when we're all done with the presentation, if we have time left, which we will, you can come off mute and we can talk about it live and we can kind of brainstorm it together. And that is that I'm guessing you still have the option of implementing some of that over on the Terraform side. So I don't know that using temporal will preclude you using CDK for things like policies and OPA. The other thing that you can do, of course, as well, is that you can put those policy checks in your orchestration. So if you remember that, let me come over here to the code. If you remember that in the activity, I had a whole bunch of logic that did things like set up directories wrapped around this CLI command. You could have libraries that say anytime you're doing a Terraform, you could structure this in a much better way that says, before I do any kind of a Terraform apply, do some policy checks. You can absolutely do that, and you can do that in the language of your choice. And so you can use, whatever policy agents that you want within that code. So hopefully that answers the question. And I see one more. When approvals happen during the deployment, is there auditing for who approved it, when, and what was approved? So if you remember, when I was doing this, when I did the approve, down here, when I did the approve, I really just sent in the environment ID. You can pass in whatever other arguments you want in through the signal. So remember where I showed you the signal took in a true? You can also, as a part of that signal, send in true. You can send in identifiers. You can send in timestamps. You can do any of that kind of stuff. So your signals can carry whatever payloads you want. Okay. And can the approval come from AD? I assume you mean Active Directory. So the Active Directory, so you're talking about having Active Directory be the, if you will, the user interface. You're going to go into Active Directory, or you're going to have some user interface that records the approval in your Active Directory. That Active Directory, if you have something that is paying attention to the signals that are coming into Active Directory, rather than somebody pushing a button in a window and it executing this approve command that I just talked about here, yes, that signal can come from wherever you want. It's just a signal that you're sending in. So you can have just a little bit of logic that says, oh, you're basically creating a temporal client, and the client is super lightweight, and sending a signal into a running workflow. Okay. All right. So with that, I do have just another slide or two that I want to show you. I want to show you just a little bit of information that we have for you as to where you can take a look and get started. So, phew, that was a lot. You can imagine I've gone about 15 minutes longer than I had available yesterday. So it was a little bit more relaxed today than yesterday. So, but what now? So the first thing is that the GitHub repository that is going to have all of the code that I showed you here is coming soon. The repository is already there. The bit.ly there, the short URL is t.mp/terraform, or you can use the QR code there. Right now, you're just going to find a README there. Come back later tonight or tomorrow, and you will have all of the sample code that I just showed you there. I've got it across a number of different branches, and I really just want to sequence it properly for you so that you can see the commit history, basically going from demo 1 all the way through demo 4. I added things to demo 1 after I already had demo 4, and so I need to do some Git hygiene. So that's coming soon. The other thing that I'll do is I already mentioned that Temporal is open source, and so I invite you to take a look at Temporal. We have a thriving community around it. I am but one of the developer advocates. We are hiring additional developer advocates because we're going big gangbusters. And so the URL that you see there, temporal.io/community, will take you to a page that gives you the links to join our Slack and join our forum and get to tutorials and get to free online courses and all of that. Now, let me leave you with one last thing, and that is, you might be wondering, I'm betting that many of you have never heard of Temporal. When I asked in the room yesterday, I would say maybe 15% of the room, maybe 15% of the room had heard of Temporal. But I wanted to share with you how it's this great kept secret, except that under the covers, I'm betting that every single one of you are using Temporal. Not as developers, but as users. So if you are a Snapchat user, you're using Temporal. Every single snap goes through Temporal. If you are in the United States, I don't know, maybe it's elsewhere as well, but I think it's mostly United States, and you are ordering online Taco Bell, Kentucky Fried Chicken, or Pizza Hut, you are using Temporal. Every single one of those orders goes through Temporal. If you are doing an Airbnb booking, you are going through Temporal. If you are using OpenAI's image generation, you are using Temporal. So yes, even OpenAI, I mentioned AI workloads earlier, even OpenAI leverages Temporal for durable distributed system orchestration. And as you can imagine, if you haven't started playing with it, I'm doing a lot with AI these days. It's distributed systems on steroids. So we have many, many, many very recognizable brands that are using Temporal, and they're using it in production. And some of them have been using it in production for years. So this is super solid technology. I am tickled. I haven't always been that fortunate in my career to be involved in technology that was as solid as this. But I will tell you that Max and Sommer are pure computer scientists at heart, and they are insistent that we handle all of those very tough distributed systems problems are implemented for you in a very, very solid way.